Algebra 2, Section 5.2, Section 7.2, inverse functions and relations. The inverse is switching your x and your y. F of x stands for the function. F to the negative 1 power is an abbreviation for the inverse. Example 1, find the inverse of these ordered pairs. All we do is switch the x and the y around. So the inverse function, the ordered pair is 2, 1, negative 2, 1, 5, 2, and negative 1, 4. Recall the vertical line test can be used to determine whether a relation is a function. The horizontal line test can be used to determine whether the inverse is a function. So in the very first graph, you can see that the horizontal line test, we only hit the graph one time, so it is a function. But the second graph, when we do a horizontal line test, it hits it more than twice, so it is not a function. Find the inverse of f of x equals 2x minus 5 and graph its inverse. So first we're going to replace the f of x with y. So the very first, the function is y equals 2x minus 5. To find the inverse, we want to transpose the x and the y around. And then we have to solve for y. Our goal is to get this in slope-intercept form. So there it is in slope-intercept form. Now we're going to replace that with the symbol f to the negative 1 power, or that says the inverse of f of x is 1/2 x plus 5/2. Now to graph it, and there is the function, and you should always label, this is the function, and this is the inverse function. Again, the negative 1 power is the abbreviation for the inverse function. Example 2b, g of x is equal to x minus 3 over 5. We want to find the inverse and we want to graph these two equations. First I'm going to replace the g of x with y equals x minus 3 over 5. Now to find the inverse, we change the y to x and the x to y. Then we have to solve for y to get in slope-intercept form. Replace that with the g of negative 1x, or the inverse of g of x. Now I'm going to graph the first function, and I changed that to put it y equals 1/5 x minus 3/5. So my y-intercept is negative 3/5, and I'm going to go up 1 over 5. Then I'm going to plot the inverse function, and make sure you label it. This is the inverse. And this is the function. Example 2c, we want to find the inverse of f of x equals x squared plus 1. I changed it to y equals x squared plus 1. Now that is a quadratic, which is a parabola at 0, 1. The vertices is at 0, 1. Then to try to find the inverse, I'm going to switch my x and my y around, and then I have to solve for y. So you have to take the square root. Remember, don't forget x plus y equals plus or minus the square root of x minus 1. To determine whether the function is an inverse or not, you have to calculate the f of g of x and the g of f of x. If both of them are x, simplified down to x, then that means they are inverse of each other. So first I'm going to do f of g of x. So I get f of 1/3 of x minus 3. Then into the f function, wherever I see x, I'm going to plug in 1/3 x minus 3. I'm going to do the distributive property. 3 times 1/3 x is x. 3 times -3 is -9 plus 9, and I get x. Now I'm going to do the g of x function, the g of f of x function. So first I'm going to do g of 3x plus 9. Then into the g function, wherever I see x, I'm going to plug in 3x plus 9. So that's 1/3 times 3x plus 9 minus 3. Do the distributive property. 1/3 times 3x is 1x plus 3 minus 3 is x. So because they both simplify down to x, they are inverse functions. So I want to determine if these two are inverse functions. I'm first going to calculate f of g of x. So I get f of 2 square root of x. Then I'm going to replace the 2 square root of x into the f of x function. Bring down the 4. Now 2 squared is 4. The square root of x is x. Multiply, and I get 16x. Now I can stop right there because it did not simplify down to x, therefore it is not an inverse function. Example 3c, I'm going to first calculate f of g of x. So g of x is the square root of x plus 1 over 2. Then everywhere I see x in the f function, I'm going to replace it with square root of x plus 1 over 2. Now, when you square a square root, what's inside just falls out. So that's 2 times x plus 1 over 2 minus 1. I'm going to do the distributive property. The 2 cancels, so I get x plus 1 minus 1, which simplifies down to x. Now do the g of f of x function. So that's g of x, 2x squared minus 1. I'm going to plug that into the g function. So inside the square root, wherever I see x, I'm going to plug in 2x squared minus 1. Simplify, the 1's go away. I get 2x squared over 2. The 2's cancel into 1, so I get x square root of x squared, and the square root of x squared is x. So they are inverse. Example 3D. When I plug that in, I get x plus 12 and then x plus 9, and because that is not simplified down to x, that is not an inverse function. And there is your assignment.